Welcome. Let's solve Leetcode 2779, maximum beauty of an array after applying operation. We're given a zero-indexed array nums and a non-negative integer k. They define what the beauty of an array is. It is the length of the longest subsequence consisting of equal elements. They want us to return the maximum possible beauty of the array nums after applying the operation any number of times. So what is this operation? The operation is something like this. We can replace any element with any integer from the range that number minus k or that number plus k. Let's go over an example here. So they give us an array nums with 4, 6, 1, and 2, and k is 2. So looking at this first index of 6, we can change 6 with any number from the range 4 to 8 inclusive, so that the array becomes, well, 4, 4, 1, and 2. If we jump to this 2 here, we can replace that 2 with any number between 0 and 4, which makes the array 4, 4, 1, and 4. Hence, notice, well, sorry, let me go back to that 1. So 1, this 1 value, the best we can do is move it up to 3 or move it all the way down to -1. So applying the operation to 1 wouldn't affect our solution. Hence, the result is 3. We can change the 6 to a 4, we can change the 2 to a 4, which means there are 3 elements in nums that are equal, given that we can apply our operation to those elements. And looking at this last example, since all of the elements are already the same, we don't need to apply any operations, so the result is 4. Okay, I think that's enough for us to get started. I think this solution I'll present is very, very clever, and so I'm somewhat excited to go over it. So let's go over this example I have here. So I've given you an example of nums and k equals 1. So I'll go over the algorithm we'll use. So they just want the subsequence. So that means it doesn't matter what order the array is in. So if this array was in, if we just switched elements around, so for example, if I change this 3 over here and I put a 7 here, is that what it was? So if I change this 3 and change this to 7, if I swap them, that wouldn't affect our answer. So that's one thing to keep in mind. So what we're going to do is we're actually going to sort nums. So sort nums so that we get, we'd get 1, 1, 2, 3, 3, 3, 5, 6, 7. Okay, so we're going to sort nums. So at the moment, it isn't quite obvious what the purpose of sorting nums was. But let's think about it, why it may be helpful or advantageous. So remember, we're given this, what's the word? This value that we can adjust any of the numbers by. Notice though, after sorting this, we can see our neighbors, meaning we know which numbers are already close to us. So for example, I know I can have an answer of at least 3 just because these numbers are already the same. But what's also important is that we can see our neighbors. And so what I mean by that is every element, like for example, this 2, I can see which numbers are close to me. So that's part of the reasoning why we sorted the original nums, because it'll make it helpful to view how many numbers fall within this given range. So the next question becomes, how does a sliding window technique, can that be applied here? So sliding window. So what we want to know is, well, what would be the size of the window? So this is a good question. So no matter what, so well, we'll always have a window. It'll look something like this, right? The window will look something like this, and we'll have a maximum number and a minimum number. Because remember now, we've sorted this. So whenever we slide our window, the minimum will always be to the left and the maximum will always be to the right. Now the question becomes, how far apart can this maximum and minimum number be? Well, remember though, we're given this k value of 1. So that means, so for example, look at 2. Let's consider 2. What's the biggest we can change 2 to? Well, that would have to be 3. And the smallest we can change 2 to, that would be 1. So that means our window size, put it here maybe. So window size would always be less than, can only be less than or equal to 2 times k. 2 times k. So what I mean by that is this. The maximum here is 3. The minimum is 1. 3 minus 1 is 2. So this is a perfectly valid window. I hope that makes sense. The maximum number is 3 and the minimum is 1. So our window, like I mean by size, it's like not really like a length. It means more like the window requirements. So the window requirements say that the maximum of the window and the minimum of the window have to fall within this range. So I'll just say that again. The maximum minus the minimum must be less than or equal 2 times k. So I hope that makes sense. And now, so what we'll do is we'll loop through our array, or this num. So we'll set a left. Left will be equal to 0. So let me move this down for us so we can use it here. So we'll set left equal to 0. So left will be here, and let's do this. We'll call this left, and we'll call this right. So what we'll do is we'll loop, and we'll set right, and right will go from I guess 0 to length of nums. Okay, so let's do that. So what we'll say is, we'll say, okay, so we'll always check, we'll always compare them. We'll always be performing this check here. So if nums, we'll call if nums left minus nums right. So what I'm going to do is the opposite of this. So if it's bigger than this, if this isn't true, so for example, if this is bigger, if this is bigger than 2 times k, then we want to adjust our window. So that means we need to move left. So left would be left. So increment left and increment left. So I hope that makes sense. So yeah, that's about it. So for example, let's run through this. So right now, right and left are at the same position. So let's look at this. So we'd have, what do we have? So we have nums at left is 1, nums at right is 1. So it's not bigger than it. So in that case, we'd go around and we'd increment right. Okay, so let's increment right. Okay, so now we're here. this would be 1. And so at this point, remember our maximum is wherever the right point is at. So 1 minus 1 is 0, which is not bigger than 2 times k. So just for notice, just for convenience, we'll set this equal to 2. Remember, because we set k equal to 1. Let's make that smaller. Maybe. And then, let's see if we can do this. That's fine. So we're still good to go. Let's move right again. So right now, remember, we're always checking if max and minimum are bigger than 2. At this point, they're not. So 2 minus 1 is 1. So we're good to go. Move it forward. 3. 3 minus 1 is 2. But it's not bigger than 2, so we're okay. So we can move it forward. Same number, 3 minus 1 is not bigger, so we can move it forward. 3 minus 1 is not bigger. We can move it forward. 5. 5 minus 1 is bigger than... Sorry, let me just go back real quick just to verify some, or make something clear. So notice though, if we're at this point, we could easily change all of these values to 2. So this is already 2. We can move one up, and all of these 3s we can move down, 1 down. So remember, that's okay because we're given a k value of 1. We can move it up 1 or up down. Sorry, so let's continue on where we were. So now right is at 5. So at this point, 5 minus 1 is 4, which is bigger than 2 times k, which is bigger than 2. So we need to increment left. So sorry, let me go back again. At this point, what is the size of the window? So let me write that down. So max max window right now is, what is this? 1, 2, 3, 4, 5, 6, which is 6. In essence, though, this is also equal to, so right is at, what's the index of right? So 0, 1, 2, 3, 4, 5. So index of right is 5. Index of left is 0. So we'd have to add 1 to it. So I wanted to make that clear. Sorry. So let's continue where we were. I wonder if I can do this here. No, it makes no difference. So let's go back to where we were. So we're now, sorry. So we advance right to this location. So at this point, 5 minus 1 is bigger than 2, which means we increment left. Now notice what happened there. What happened? So right didn't work, which means we had to increment left. Notice how far right and left are. So now right is at index 0, 1, 2, 3, 4, 5, 6. I wanted to point something out. So right is at 6. But left is at what? Now left is at 1. So notice though, if we subtract 6 minus 1 and add 1 to it, we still get the same value of 6. So my point is, remember, this was our last valid window. But remember, we moved right here, and then but then we also moved left here because that failed our requirement that the maximum minus the minimum should at most be 2. Notice though, we shifted right and left, which means this. We preserved our window size. Let me say that again. We preserved our window size. When we move right and we move left, we preserved our max window size, and that's important. Okay? So we're at 5 and we incremented left. Now we go around again. So now right goes here, that's 6. Is 6 minus 1 greater than 2? Yes, it is. So we increment left. And again, notice how the maximum window size is preserved. It stays the same, unchanged. Okay, now we move right here to 7, and because of that, 7 minus 2 is 5, so we increment. Sorry, so 7 minus 2 is 5, so we increment it here. Okay. Again, same window size, max window size in fact. Okay, and now we, at this point though, the way Python works, this would equal 8, and we exit the loop. So all we need to do now is basically do this here. Where did I have it? Well, here. So remember what we had here. So this 5 was the right endpoint, and this 0 was the left endpoint, and we add 1 to it. And that's what we do at the end. We actually just return that. We return right minus left plus 1. And that's it. So I thought this was a fascinating approach to this problem. And yeah, I don't, it was just fascinating for me. And I wanted to share with you, and I hope you understand it. If not, let me know so I can review it again. But I think that's enough for us to implement it. So let's go over this here. What do we do? Okay, what do we do? So we start, so for right in range length of n, we forgot to set our left pointer, so left equals 0. And then what do we check? We check if basically we do this here. We can probably just copy that. Okay. So let's change this to left to make it maybe a little bit more understandable. Sorry, I think this is backwards. Sorry. The right pointer is sorry, this should have been right all along. Remember, we sorted it, so this is the bigger number. This would be left here. My apologies. So right, and here's left. And what else? Oh yeah, so we increment left here. Left plus equals 1. Other than that, we return right minus left plus 1. I'm going to make a small change here, assuming this works. What did I mess up on? Oh, I get it. Actually, do I? Left equals 0, right in the range length of n. That's correct. Right minus left. Left equals 0 for right in range length of n, and a right minus if it's bigger than that should work. Oh, I'm so stupid. The first thing I told you was we didn't sort the numbers. I'm sorry. My apologies. What is it? N.sort. Okay. There we go. I'm sorry. All right, cool. One thing that well, I'll just submit it just to be sure. One little small thing, it's not really a big issue, but that I'll probably do is I just notice that for every time we go through this loop, and remember we're going through this loop, how many times are we doing it? The length of it can be, I don't know, what is that, 10,000? So we're going through this loop 10,000 times. So this is just a little thing as an engineer I like to do, is there anything that we're doing 10,000 times or however many times that we can reduce, that we can remove? So first of all, there isn't a lot of code here, but there is something that we're doing over and over again that we can remove. So notice for every loop, iteration of the loop, we're multiplying 2 times k. So what I recommend is, well, why don't we just set, we'll just set k equal to, well, let's do this here. Let's do it backwards. Let's put a k here. And we'll just set k equal to 2 times k. And then we'll just remove it. I know it's very subtle, and it probably will not make any difference whatsoever, but I think it will. So I think it will. Just things like that as an engineer or coder that will want to try to be aware of or be cognizant of. So that's just my little tidbit to you. In any case, if you found this enjoyable, educational, or helpful in any way, please consider liking or subscribing. Other than that, have a wonderful day. Take care.